In some cases, the trinomials that we are trying to factor may have two variables. In those situations, we want to stay true to the practices that we already have and hope that the skills that we've already developed can be applied to a two-variable situation. Looking here at this trinomial, 12x squared y minus 46xy squared plus 14y to the third, we should immediately recognize that these three terms have a greatest common factor. Regardless of whether or not there's one variable or two variables, the GCF should always be our first stop. So looking at each one of the terms individually, we see that we have a greatest common factor of 2y. Removing that 2y from each term leaves 6x squared as the first term, minus 23xy as the middle term, and 7y squared as the last term. You'll notice now that 6, 23, and 7 have no factors in common, nor do the variable parts, x squared, xy, and y squared. At first glance, this does not fit into our category of trinomials that we already discussed wanting to be able to factor, those that fell into the category of ax squared plus bx plus c. We did see an example in a previous video about one where the powers were double each other. So instead of this being a 2 and this being a 1, maybe it was something like 6 and 3. It turns out that this situation that we have here is another very common factoring situation where we have two variables. Now, this is not, of course, the correct answer, but just take a look at the reasoning that will go behind this. Imagine we are attempting to factor 6x squared minus 23xy plus 7y squared. Just for the sake of conversation, I'm going to place 6x here and 1x there and 7y there and 1y there. That'll ensure that when I do the first part of the multiplication, I would get 6x squared. And when I do this part of the multiplication, I will get 7y squared. But look what happens when you attempt to do those middle terms. You attempt to do these two and these two. Both of those multiplications create an xy term. The one on the outside creates negative 6xy. The one on the inside creates negative 7xy, which is, of course, negative 13xy, which means this is not our correct factorization. But it does show us that if we follow this process, we are going to get a term in the middle that works with 23xy. So erasing all of this, let's go back to the beginning and let's reconsider that trinomial from the very beginning. And let's think about it in terms of our technique that we already developed, the AC method. If I take my AC, which is 6 and 7, I get a product of 42. But then I need a sum of negative 23. So thinking through the two factors, or the factors of 42, we've got 42 and 1, 21 and 2. That seems like a good candidate. 14 and 3 are a little bit far apart. So let's go with 21 and 2. And now we, of course, both want both of them to be negative because we need our sum to be negative in the middle. Splitting up that middle term using some grouping, we can rewrite that middle term as 21xy minus 2xy plus 7y squared. So we've split our middle term into negative 21xy and negative 2xy. Factoring by grouping, we look at the first set of terms, these two. We see a common factor of 3x, which leaves behind a 2x minus 7y. Of course, if we want this back half to work, we're going to need 2x minus 7y to be the common factor there as well. In order to get that to be the factor out of these two, we're going to have to remove a minus y. That'll sign change for the 7. It will sign change for the 2xy and create the common factor that we got out of the first parentheses. One more step. We have our greatest common factor. We have our common factor and our other binomial. So looking at this multiplication, you can see right here, we create negative 21xy. Right here, we create negative 2xy, which is exactly the total of negative 23xy that we needed.